following movie, we'll use selection recipes to create simulation files that will be able to then swap out the geometry for something different. We'll start from scratch creating the geometry. And to be able to use selection recipes and the attribute functions of it, what we'll do is we'll assign some attributes to the geometry. We'll begin by selecting the solid body first, and this will give it a name TETmesh because we want to put a TETmesh on this body. Next, we'll select some faces. The first face that we'll select we'll call 1 pound load in Z, because we want to put a 1 pound load in the Z direction on that face. And then we'll put another name on the bottom face here, which will be fixed. This is where we'll put our fixed translation constraint. Alright, great. Now that we've defined that, we'll create our simulation files. And instead of calling this block fem, we'll call it selection recipe fem. And the solver environment that we select does not matter. For this one, since I have the Nastran solver, I'll use that. And then in the fem, we'll create our first selection recipe. We'll call it TETmesh. We'll select anything from the entire model, but we want to be looking for polygon bodies, and we'll look for that body by its name, TETmesh. And if we've got this right, when we say show result, we should see that body highlighted. And we did. So that looks good. And now we'll use it to create our TETmesh. We're not going to select the body off the graphics screen. We're going to select the body from selection recipes. Then we can define our mesh recipe. We can put it in element size, any other parameters of the mesh. All of that will be remembered. All right, and then the default for the material will be to inherit it from the body. So next we'll create our sim. We'll call that selection recipe underscore sim, and we'll add the fem to it. We'll create a linear static solution in it. We could create any kind of solution here. We could create a modal one if we wanted to as well. And then we'll begin by creating our selection recipes in the sim. So here, instead of looking for polygon bodies, we want to look for polygon faces in the entire model. First one, the name will be fixed. And again, we'll do show result to make sure we've got it right. And you can see that face is selected. However, we should have named it. We can fix that later. So this next one we'll call 1 pound load in Z. Again, polygon face by name, 1 pound load in Z. And we'll check it at the tab, and there we go. Looks good. And then we can rename that one to fixed. Okay. Next we'll put in our constraints in the same fashion. This one, because we already had the selection recipe pre-selected, it looks like it's already picked it up. Let's just go through that again with nothing pre-selected. So we'll pick the selection recipe fixed for our fixed translation constraint. And then for our load, we'll create a 1 pound load in the Z direction, and we'll select that from the selection recipe 1 pound load in Z. All right, so here let's do a test solve, make sure we got it right. Looks like the solver setup check has found an error. There's no materials to find. That's because when we created our block, we didn't assign a material to it. So let's go back to our master part, and we'll assign a material to it. Then we'll go to the FEM, we'll update the geometry there to make sure it gets the updated material change there. And then back to the sim and we'll solve. All right, this time solver setup check didn't find any errors and the solution was successful. We can check the results. We'll take a quick look at displacements and stress. Everything looks fine. All right, great. So now that we've created this with a selection recipe, I have another part that I've created in the same fashion that is completely different, but has attributes assigned to the holes here on the flange that are fixed. Those are have an attribute named fixed, and then the top face is the 1 pound load in Z. And of course I have the body named tet mesh as well. So what we'll do is we'll go back to the FEM, right click on it and say replace ideal master part. And here we'll swap out our block for our flange. As soon as I say OK, it updates the mesh. We'll go to the sim and you'll see it's already assigned the loads and constraints on there, and we're ready to solve. There you can see our no translation constraint on there and our 1 pound load in Z. So here we'll do a quick solve. And take a look at our new results for displacement and stress. And that concludes the demonstration.